Hello friends. As part of building enterprise data warehouse using Hadoop ecosystem, we are in data load process. So far we have spoken about Hive architecture and Hive data modeling using Hive, and also pulling data from relational databases to Hadoop based systems using Scoop. Today we will cover another topic to get data from other sources like mainframes and XML external applications into Hadoop. So as part of data loading, we have seen pull strategy where scoop import is extensively used, and it will connect to remote database, runs as MapReduce job in Hadoop cluster, and copies data from remote database to Hadoop. And you can go back to the previous videos if you haven't seen scoop import. And the other strategy to get data from source systems is push strategy, where source applications will actually push data uh, to you, and it's your responsibility from there to load into Hadoop. So Hive can be used to load the data. Hive is one of the options. It is not only the option, but one of the options where you can leverage to load data which is pushed from source systems to your file servers uh, uh, to HDFS. So we will see how it works. So now we are getting into more details about push strategy, and typically mission critical OLTP databases prefer to send data to targets rather than let targets connect to source systems and pull the data. They will give you the data uh, on a grid upon specification, and then it's your responsibility to copy the data into whatever target system it is. In our case, it is Hadoop. The reason is when you use uh, pull strategy, and if you are trying to connect to source system, if you go back to scoop import, there is something called num mappers, and a developer can tweak it to improve the performance. It might or might not improve the performance to copy data from the source database into target system, but most likely by increasing number of mappers, it can cause contention on the source system to the applications running on the source system. So for example, we are trying to build a warehouse on retail database as part of this course, which is provided by Cloudera. If you visualize it, the source system can be a major retail store or a e-commerce platform where you sell products, and if you try to pull all the orders using higher degree of parallelism, it will start using all the database resources on the source system, and it can cause the actual retail application that is supposed to run pointing to that database. So to cut the long story short, it is not very good idea to pull data using tools like Scoop, where parallelism can be easily increased or decreased, to pull data from the mission critical OLTP databases, even though they are relational databases. So the approach will be that source system will give you the data, and then you have to load into Hadoop. So there will be a staged environment called file servers, which will act as a client for Hadoop. So you need to have Hadoop binaries on that, and you will copy the data into HDFS. We will see little bit details when we do the demo, but that is the overall approach. And also closed mainframe systems, not it is not as easy as connecting to a relational database and get the data if you want to get data from mainframes. Typically mainframes guys will take the ownership of providing you the data. So as a target system, you need to negotiate the specification in which they should give you the data, and then you have to develop your downstream applications. Uh, so that is the traditional way of getting data from mainframes, and you have to follow that in most of the cases if you have to get data from mainframes. And then another source for an enterprise data warehouse or data platform, uh, irrespective of the technology you are using, is third-party applications. Even there, they might use tools like TIBCO, MQ, or some other middleware technology, and it's their responsibility to give you data in interoperable fashion. So source systems will give you either in JSON or XML or some delimited text files, and you have to have an environment where you can stage that data, and from there you can load into Hadoop. So there are other sources also and other ways also, but within the scope of Hive, we can deal with these kinds of data to get data from staged file servers into Hadoop, and that's why I'm limiting the scope till there. So for all the cases which I have explained earlier, where a source database or a mainframe system or a third-party application push data to you in a file in some format in files, into a staged location. From there to copy data into Hadoop, you can use something called Hive load command, and we will see more details about it as part of this video and few more videos later. So there are some limitations which you need to understand before using Hive load command. We will see those limitations hands-on also as part of the next video. So one thing you need to keep in mind is files that needs to be copied into Hadoop. If you go back and if you see the Hive queries which we have ran earlier, we have created tables. So let me launch Hive. We have created tables already, and when we actually create tables, uh, we actually tell the format of the file, and let me describe a table, then you will understand more about what I'm talking. So use retail ODS. So this is the database which we have created as part of the Hive data modeling in previous videos. If you want to recollect, you can go back and you can understand. So let's describe formatted on one of the tables. In this case, let's say it's customers, and if you look at the details, first you have the column names and then the location. So these are all Hive table properties. Okay, so Hive table properties are the column names and HDFS location. Okay, and then input format in which data will be read. By default it is text input format. You can change it to other formats also, as we have seen earlier. So these are the properties which the files that needs to be copied using load command should match. So in this case, if you want to copy data into this customers table, so it should be a text file, and then the each field should be delimited by pipe, and there should be around 9 columns in each row, and each column should be delimited by the pipe. So these are the properties that needs to be followed. Even if you put some junk in the file, and if you try to copy, data will be copied, but when you try to run the queries, you might see incorrect results. That is why Hive is known as schema on read, because when you run load command, it does not do the checks whether the data is matching the properties of the table, but it will copy without doing any such checks. That's why it is, as it is not doing any checks at runtime, at write time, it is called as schema on read, whereas our traditional databases are called schema on write. It is very important interview question, uh, and one of the difference between Hive or any Hadoop based database is that they are schema on read, whereas traditional RDBMSs are schema on write. Okay, what does that mean is the file properties and the the table properties, the Hive table properties, and the file you are trying to copy from stage location into the table should match. Otherwise, uh, your results will be inconsistent when you try to query the data. So internally, you need not worry about the second statement. Load will use file system APIs to copy files from local file system or HDFS to HDFS. It is mainly for Java developers. If they want to know internally how it goes, there is a API called file system for Hadoop, and internally this load command will use that API, and it does not use MapReduce to copy data into HDFS. Okay, and this is the syntax. It has so it and the last one is the example. So load data in path, and then path name. The file path can be either a HDFS path or local file system. In our case, we are talking about copying data from local file system into Hadoop. So the file path will be local, and then overwrite. If you want to just replace the table every time you load into the table, then you can use overwrite. Otherwise, it will append to the table, so new data will be added to the existing table without touching the data under the table. And then if you want to deal with partitions, there is a partition clause as well. So this is the plain syntax of Hive load command. It's very straightforward and very few options. Local is the important one for the course at this time. It is used to copy from local file system, which is Linux file system, to HDFS pointed by Hive table, and overwrite is that old data will be lost, and partition is to copy data into partition, and this is the syntax. So let us try this. We will not be doing demo in this video. We will take care of it in the next video, but let us see how this load command will work. Okay, first let us create a text file, vi tst.txt. I 1 2 3 4 5 6 7 8 9 10. Okay, and I am getting into Hive. Create table test t string, and then I am running this load data command. See, this is the path where I have created that test.txt file, and this is the table which I have just created with one column called t, and you can see the results. Select star from test, and you can see all the values we have just added. Okay, so that's it for now, and we will see much broader demo using the tables which you have created earlier, and how we actually load data uh, into Hadoop using Hive, and that demo will cover different aspects of it. but on a real data, not just spurious data which I have shown you earlier. I hope you are enjoying the series so far. See you in the next video. Thank you. Bye.